Hello everyone, in this video I'll be explaining on the application, advantages and limitations of dark field microscope. This dark field microscope is also an optical microscope which is also called as dark ground microscopy, which describe microscopy methods in both light and electron microscopy, which exclude the unscattered beam from the image. As a result, the field around the specimen, that is, where there is no specimen to scatter the beam, is generally dark. This is similar to the ordinary light microscope. However, the condenser system is modified so that the specimen is not illuminated directly. The condenser directs the light obliquely so that the light is deflected or scattered from the specimen, which then appears bright against a dark background. Living specimen may be observed more readily with dark field than with bright field microscopy. A dark field microscope is arranged so that the light source is blocked off, causing light to scatter as it hits the specimen. This is ideal for making objects with refractive values similar to the background appear bright against a dark background. When light hits an object, rays are scattered in all directions. The design of the dark field microscope is such that it removes the dispersed light so that only the scattered beam hits the sample. The introduction of a condenser and or stop below the stage ensures that these light rays will hit the specimen at different angles rather than as a direct light source above or below the object. The result is a cone of light where rays are diffracted, reflected and or refracted off the object, ultimately allowing the individual to view a specimen in a dark field. Coming to the applications of dark field microscope, it is useful for demonstration of very thin bacterial structures which are not visible under ordinary light microscope or illumination, since the reflection of the light makes them appear larger. So structures which are very thin, like the flagella, can be observed. Next, frequently used method for rapid demonstration of bacteria such as Treponema pallidum in clinical samples can be examined. Next is demonstration of the motility or locomotion or movement of flagellated bacteria or protozoa. Those bacteria or protozoa which has flagella or flagellated bacteria can be observed for the motility or locomotion or movement under this dark field microscope. Next is it can be used to study mounted cells and tissues and also marine organisms. Next, coming to the dark field microscope advantages. First is dark field microscope is a very simple yet effective technique, and it also live and unstained biological samples can also be examined. Dark field microscopy techniques are almost entirely free of artifacts due to the nature of the process. Next, to the limitations of this dark field microscope. The main limitation of dark field microscopy is the low light level seen in the final image. Next is the sample must be very strongly illuminated, which can cause damage to the sample. So these are the application advantages and limitations of dark field microscope, which is also an optical microscope used in the laboratory for diagnosis.